lunch break, and after, I believe, like, Ariel is still talking on the main stage, isn't he? But yeah, so let's start with our first workshop after the lunch break, and we'll go with the workshop that has been, that was presented today in the morning. So if you attended that, like, you're free to skip it. But Vlad and Steve will be talking about dissecting everyday zkTLS. Yep, mic is yours.
Hi, like you said, I'm Steve. This is Vlad. We're from Opacity Labs. There's our socials at the bottom if you want to contact us or check us out. Today we're going to be looking at sort of behind the scenes, some of the inner workings of Opacity Network. It's a great quote. HTTPS has been talked about several times today, so I will spare you guys that a detailed look into that, but essentially there's a shared secret between the server and the client that they use to encrypt the communication. The problem is that it is a shared secret. They both have the encryption key. So the client can, if the client wants to share that data with someone else, there's no verification, there's no way to prove that that data came from the server. Big thanks to Ethereum Foundation and Henrik's team. What we're building would not be possible without what they're doing. So we are standing on the shoulders of giants. There's a lot of work that has gone on to make any of this possible. So what Opacity is trying to do is fix the poverty of verifiable data. And we want to empower devs to build an entirely new class of applications that is now possible because we can have verifiable and portable data. We're rewiring the internet. New things are possible. We want to build the tools so that the app developers can take full advantage of it. So how do we go about getting the raw materials for zkTLS? Like I said, we've got a encrypted communication between a client and a server. How do we intercept that? It's, you know, each server, each application that you interface with will have, excuse me, will have their own way of formatting that data. And so we've actually got to go in and look. People like Vlad do the hard work of dissecting that and figuring out how to get the information we need to come back from the app so that we can go ahead and verify it and make that data portable. So I'll turn it over to Vlad so he can show you what he does.
Hey folks, so yeah, I'm gonna show around like how do we actually get the raw materials from everyday web activity. We use at Opacity Postman, basically a software where we actually store all the requests. So with documentation on like how everything works. Beton proxy, we usually use that to intercept requests on like mobile apps, which we can actually later leverage to extract data from different apps. On OpenSSL, we actually use the SSL certificate to actually sign that cryptographically what we obtained is actually what we obtained, right? So I'm gonna give a live demo on like how to actually get the raw materials from like the New York Times, and then we're gonna generate a proof. Basically we're going to like, let's say, New York Times. Whenever you get like, what you see is like an HTML, and let's say we want to actually prove that what we see is actually real. We can get like the curl from like this given request, which is the HTML of this website. We can import it to like Postman. We can do the request, and we can actually see the HTML, which later we can actually generate a cryptographic proof of like this data. And yeah, that's it. Turn it back to Steve, which will explain how to actually cryptograph it.
Yeah, so once we've figured out basically what we're looking for in the data, then we can bring it into the TLS notary. Yeah, once we know what the format of that data coming back is, once we have the encrypted data from the TLS notary MPC communication, then we can use that to generate a proof, because we'll have the plain text, we'll have the signed in ciphertext, and we'll be able to use those together with, you know, knowing the content and the format of that data that came back to generate generalized proofs from that data. So quickly on how the notary works, there's two parties, the notary and the user or the client. Neither one of them has the full encryption key to see the plain text that comes back from the server or to make a request to the server. They have to work together using MPC to do that communication. And that way we have assurances that the information that we're looking at is indeed the information that came back from the server, that it wasn't tampered with in between, and also that that it's authentic, it's the correct information, and that we got it from the server that it's supposed to come from. So to see it all come together, we'll do a quick example of the TLS notary from Ethereum Foundation, just to show how that works on another quick example.
Cool. So we're gonna use TLS notary to fetch the Apple's stock API and actually create a cryptographic proof. Oh yeah, sure. Oh, can I? Let's see. Good enough? Yeah. I mean, I'm using the TLS notary example app. Basically, I created a proof for a stock, for the Google stock from like Apple.com. Are you able to see it properly? Yeah. Yeah. So we made a request to actually the quote of the Google symbol on like the internal API of Apple that all the mobile apps, mobile devices use. We can actually attest like the price of each of the quote and everything. Like, we pull the data from the mobile app, and that it's real. Yep.
So you are using the notary server from TLSM?
Yeah. Yeah. We pulled the data and we created our proof.
Okay, so that's not attested by your AVS?
Not yet.
Okay.
Yeah. That's it. To be honest.
So how would you figure out the request that's with that zkTLS?
Which one?
How do you figure out which request to make to that total server? That's
Yeah. So yeah, basically intercepted all the requests being made by my phone when we opened like the stocks app on my mobile phone, and was able to figure out which one is actually to like gather the price of the specific stock. Yeah. And then I just replicated it in Rust, the request.
any recommendations that you have some experience how to quickly find the correct
It's quite easy, to be honest. Basically, you will just need to connect your mobile phone to Mitten proxy, actually trust the certificate. You will require root or jailbreak on your device to actually be able to like, depends so really on like the security of the app itself. Most of the apps have like SSL pinning. Basically, they know the certificate of the server that they want to talk to. So basically, if you're a man in the middle, they're going to be able to see that who are they talking to is not who they want to talk to. So they're basically not going to talk to you. So with jailbreak, there's like multiple tweaks that you can use to actually bypass that. And then you are able to see clear traffic from like all the apps on your device, unless they have like some, SSL pinning on their app. Basically, you will need something more sophisticated, like writing some scripts to actually debug it and patch it. But yeah.
He says it's quite easy. I think it's easy for him. It's probably not easy for the rest of us. That's actually, to be sort of clear, like Opacity, what service do we provide? We're an AVS that provides a network of notaries, and we provide an SDK that has a lot of the hard part figured out of making these APIs accessible for developers. Are there any other questions?
So I have a question actually. So what's the overhead to actually run the zkTLS over the requests you showed? Because like what we showed were just two requests and the data we want to notarize also. So what's the real overhead between like the normal TLS session?
There is some latency because of the MPC. It takes some extra just bandwidth. There's more communication that has to go on for that. As far as quantifying what that is, I'd ask Henrik if he has a metric to use on what that overhead is. So three or four zeros. But we're knocking a couple of those zeros off in the near future, right?
Hopefully.
Right. So any more questions? If no, then thank you guys.
Great. Thank you.
And now I believe we're heading to a short break.
A personal